Hi, everyone. My name is Dilyara Zharikova, and first of all, I have to apologize that I'm not in year one with you, and the first author unfortunately cannot give a speech today. So I'm going to share with you our recent work, which is called Knowledge-Based Response Generation with Persona, and the title fully reflects the sense of the work. So just let's start from the brief introduction. The grounding of the conversations is a very important task, and we always want to somehow take into account additional information for the considered task. We would like to have take into account user's persona description and additional knowledge. In the considered task, the persona description is like a textual description, is a list of sentences, and the additional knowledge is also a list of different sentences which could be chosen for grounding of the conversation. So I will tell you about the data set a bit later, and let's just firstly I will briefly tell you what is the knowledge grounding, what is the persona grounding. This is a very simple task that simple in the consideration. The task is to take into account some additional knowledge that could be extracted from the external knowledge base. And this task is very important because it gives you an opportunity to add the knowledge to the any language model, for example, for generation, which allows you to take into account, for example, the most recent knowledge, the most recent use, the most recent weather forecasts, and other things. So this is somehow give you opportunity to keep in touch with the recent news in the world. So the other task, that is the persona grounding, is gives you an opportunity to somehow explain the dialogue system, how to behave. So for here you see the example from the most classic data set, that is persona chat. You have two persona descriptions for each of the collocators, and you're just simply take into account this information in the dialogue. So for now, of course, all of you know something about prompting, about ChatGPT and other things that allows you to, not allows, just persona grounding allows you to add some persona in the prompt for the large language model, and to explain how to behave, about his persona or instructions, etc. So it's like persona description is about how to behave the dialogue system and other things. So both of these tasks are very important because we have additional participants in our conversation, in our presentation. So okay. Let's continue. So on the first workshop of customized chat grounding persona that was conducted on the October 2022, so in the previous year, in the end of the previous year, they were presented a focus data set and a shared task. And the shared task was presented this focus data set that contains dialogues that emulates conversation between a machine and a human. It's like assistant and a human that helps you to somehow pick up your travel destinations, for example. And it also contains more than 12,000 dialogues, and more than 5,000 Wikipedia facts, single sentences, I mean, unique Wikipedia facts, and more than 32,000 persona sentences, persona description, unique persona descriptions. So it's very huge data set, but still it's it has a very structured and type, and therefore it's not very common and could be reused for in general conversation. But still, this is a really good data set, and it has quite good quality. So the shared task was to train the model that will take into account the knowledge and the persona sentences and will generate the next sentence in the data set. So here you can see some example from the focus data set. So we have, like, you can see here the dialogue is like a list of sentences that discuss some, for example, travel destinations, and you also have a persona candidate for each turn in the conversation. So you have a persona candidates, like it's 5 persona sentences, and for each step of the dialogue, so for each turn of the dialogue, you the system may utilize any number of these 5 persona description sentences. So it could be like 0 of them, 1, or several. And there is also for each step presented a knowledge candidates list. So it's like 10 knowledge candidates, 10 sentences, and for each dialogue turn, the only one knowledge candidate is utilized. So like for persona, you can pick up any number of sentences, and for the knowledge, you can pick up only one candidate. So that's simple. So you have like a data set where each step in the dialogue is described with the several persona sentences and a single knowledge sentence that are utilized to generate the response from the system. So what are the proposed system components in our system? So we have 3 parts. The first part is the knowledge extractor, the second part is persona extractor, and the next part is generation models. That is very convenient for the system, that we have like, first of all, we need to select the knowledge sentence, we need to select persona sentences to be used, and we then can just simply add these sentences to the dialogue context and feed to the language model to generate the next utterance. So let's start from the training pipeline. Here you can see the utilized pipeline. We have like knowledge extraction, persona extraction, and response generation. And on the first part, that is knowledge extraction step, you have like, you're just taking into account all the persona descriptions. So the persona of the human that you're conversing with is the same for the whole dialogue. These 5 sentences are the same, and therefore we can just simply take all of them into account when we are choosing the appropriate knowledge candidates. So the knowledge candidates that could be used. So we're taking into account the persona, the user utterance, and we are selecting the knowledge sentence. So after that, when we have select knowledge sentence, we are utilize the persona descriptions, the knowledge sentences, the true knowledge sentence on the training step, and the user utterance to pick up the persona sentences that are going to be used for the generation. And on the generation step, we just simply utilize the gold labels, the gold persona and gold knowledge that are utilized for in the data set, so for the generation part. So during the inference pipeline, the situation is the same, but we do not have like the gold persona and gold knowledge from the data set. So therefore, they are just simply replaced with the predicted knowledge and predicted persona during the persona extraction and response generation steps. So just a bit more about experimental setup that was conducted in our work. So we utilized 2 different models for persona and knowledge extractors. So it was like DBERT architecture, DBERT model, and MPNet model. So the both models were trained for several epochs on the single GPU card, and we also utilized BART-based model as the generation one that takes into account the concatenated predicted persona and predicted knowledge sentences. So if we proceed to the results of the of the experiments. The first part is about knowledge extraction. So we just have studied this Dilyara and InfINet embedders for choosing the particular knowledge sentence to be used in the current dialogue context. So you can see here that we tried to compare also default without fine-tuning models, and while InfINet showed like significantly better result than Dilyara without fine-tuning, after fine-tuning InfINet showed even better results. So we decided to utilize this architecture in our experiments for knowledge extraction. Persona extraction is like the task for choosing the 0, 1, or several, so any number of persona sentences to be used for the generation of the next response in the dialogue. So we have also tried Dilyara and InfINet embedding-based models. So you can see here the first line, this is always 0. So when you when you are trying to predict that we do not use any persona sentence, and it gives you like a very quite good accuracy for personas like 86, as you have seen already. The next slide, you can see that persona accuracy is like for other models for even worse. So the stupid approach is like gives you like 86 accuracy, and therefore and this is because of the imbalanced data set. So therefore we decided to like utilize additional features like weighted entropy loss, like focal loss, and therefore we just get that focal loss give us just a bit better results than usual entropy loss, but still the fine-tuning of the InfINet model gives us significantly better results than the default one, than picking up always zeros. So when we are just getting to the next part, when we are talking about the response generation, so imagine we have like our KRGP model, that is knowledge-based response generation with persona. So this is our model, and you also can see here comparison with 3 different models. The first one, Focus, is from the authors of the data set, and the 2 from the leaderboard during this shared task. So the first one, as you can see here, the persona accuracy given by the authors of this paper is like the same, approximately just a bit lower, no, just a bit higher than just default accuracy when you predict only zeros for the persona. So it's like it definitely should be improved, and all these models also show the bad result for persona accuracy. We also see that for knowledge accuracy, we are comparable with the second approach, and for iteration task, we got the highest rate, the highest metrics that are picked up by the authors of the data set for the leaderboard during these shared tasks. So you can see here that our results are like we have like state-of-the-art results in terms of persona extraction and response generation. So we see here the significant difference in some scores. So I think this could be also affected by the fact that we have utilized other architectures, but in general, I have to tell that most of all of these papers utilize like the very usual and reasonable approach. That is like first of all, just select the knowledge, select the persona sentences to be used. After that, just simply concatenate all this information: selected knowledge, selected persona, dialogue context, like several previous utterances, and just simply fed it into the generation model, and it will give you really good results. So just the taking into account the knowledge and persona is simply like a concatenation with the dialogue context for all of these papers. So the recent example of the system predictions. So you can see here the user question was like the place. about some place, like travel place. We also have like 5 persona candidates, and we also have 10 knowledge candidates. And as you can see here, first of all, what are we doing? We are just taking all these knowledge candidates and taking into account user question and persona candidates like affected. You are predicting the knowledge. So we are just simply picking up the knowledge because it's like 10 sentences. We have to pick it the first. And there's definitely one sentence, one gold sentence. So we're just taking the predicted knowledge. And after that, on the second step, we are taking into account the predicted knowledge, the user question, and we are simply choosing the persona sentences to be used in our generation. And only after that, when we have selected the persona sentences, the predicted knowledge, and after that we're taking into account our user question also and generate a response. So everything is very like direct, reasonable pipeline. So we also have like a very small ablation study, which is the study of the effect of extractors on the generation. So we have like comparing the true persona knowledge sentences from the data set and extracted, so used by our extractors. And we can see here that the difference is actually is not very high, the difference from the, in the scores, but still it presents. So we also see that persona extractor has a significant negative impact on the metrics. So like persona affects the most, and probably this is the reason why other papers were getting quite worse results, because they have a really low scores for persona extraction, and also accuracy is not the best choice for these imbalanced persona data sets, probably. So to conclude, we presented a knowledge-based response generation with persona system, which extracts the most relevant facts from general knowledge, select the most appropriate sentences from the persona description, and after that generates a response based on this persona, knowledge, and dialogue context. We also achieved a state-of-the-art on the leaderboard as of today on this task. And we also, but unfortunately, we haven't participated in the workshop because we have learned about it just like a week before, or like more than a week before this shared task, and we haven't time to participate. So the also very important part of this is like the system is based on the models of these sizes, like 100, 140 millions parameters, which makes it a production ready approach in general, but still the data set is not, I think, the best choice for the production, for the general. It's not very common. So therefore, I think the using in production for the particular situation about traveling is like okay, but for general tasks it's not the best choice. The data set, but the system showed its good quality. So thank you very much for your attention. If you have any questions, you can ask it.
Thank you, Diля. Do we have any questions from the audience? I have a few, actually, maybe more than a few, because it is really interesting topic to me, as you would expect it. We are, if no one knows, I'm also worked with Dilyara for, I think, 3 years or so. So we are close colleagues. I'm interested in the metrics you've been used. Could you please switch to the slide with the results? Yeah, the results. Am I understanding correctly that the knowledge accuracy, this is how you measure it by the like comparing extracted strings from the data with the golden strings or something?
No. So thank you for the question, Valentin. The persona and knowledge accuracy is like really accuracy scores, because there is a list of the sentences for the choice, and we are just simply checking if we have chosen the sentence correctly. So it's like a list of 10 sentences of the knowledge, and you're just picking one, and you are either 1 or 0.
I see. Yeah, thank you. But the next question is, for the response generation, you're using Blur and char F++ and Rouge. All of them, as far as I understand at least, they are comparing the either tokens, either n-grams for char F++. And don't you think that these metrics are not really suitable for response generation comparison, like evaluation?
That's a good question. We actually, after this paper, we had a big seminar, by the author, the first author, Dmitry Kosenko, on the topic of what are the good metrics for the response generation evaluations. So we have not concluded, we still, after this seminar, we still haven't decided what are the best choice, because all this, I think the best metric is like human evaluation with a good assessors. Yeah, so we just showing here these metrics just because the authors of the first paper, which are also the author that are also the authors of the data set and the organizers of this workshop and shared task, they have chosen these metrics as for the leaderboard. So we decided to utilize them. Yes, of course.
Okay, of course, I understand that this is the metrics from the shared task, but in my opinion, when we are speaking about generation, we should consider some other metrics, for example, like BERT score or something like this. Have you thought about it?
We have thought about it after the task, after the experiments were done. So probably, yeah, you're right. We have to consider like more metrics and probably add it to the paper for the future, for the publication.
I think that the adding more metrics, maybe not necessarily, is the way. I'm just saying that maybe it would be nice to have some reproducible baseline, I mean, aside of your own system, which you could compare with using these additional metrics, and maybe some small human evaluation will be also nice, because every time we are speaking about generation, any generation, starting from machine translation and ending nowhere, it would be nice to have some more fair comparison. You said the human evaluation is the best.
Oh, yeah, definitely. I think we are also releasing the code for our baseline. So if we are talking, the problem of like the systems we are comparing to, the code from the repository they are providing for the reproduction is like very somehow differs from the approach they describe in their papers, and therefore we also release our code and our model, our trained weights for this task for the future.
Well, this is really great that you release it. I also have, if no one else have no questions, then I have a question about the persona itself. It seems that persona here is described as several sentences. So it's more like a philosophical question. Do you think is it okay to describe a persona like with a bunch of sentences?
That's a good question. I think it's like we have like wrote about in limitations. So the data set is really somehow specific, and the description of the sentences, the persona is described only with 5 sentences that are fixed for the whole dialogue. Yeah, that's definitely not enough, because as we all have seen during this past month about like prompt engineering and the ability to write a good prompt or a good description on how to behave for the large language models. So you can significantly affect the generation just somehow changing the persona descriptions. So therefore, I think, yeah, the persona should be described as in details as possible, because the 5 sentences are not enough, though. So the only reason, I think, it's like they had a very specific topic in these data sets, like about traveling, and probably that they tried to consider that 5 sentences will be enough for this restricted topic.
I see. Thank you. I think I have enough questions for today. So if there are no additional questions, then thank you, Dilyara. It was a really nice talk.
Thank you, Valentin. Goodbye.